Hello guys, welcome back to the channel. So for today's video, we will be solving this numerical pattern. So let's decode this. So this is the raw pattern for n equal to 4. We will be printing 4, 3, 2, 1 in grid format. So what we will be doing is we can analyze the pattern. Here the numbers are shrinking uh, as we move towards the center. And like the question is, how do we calculate this? So after debugging this, the approach that I found is okay, we can transform this raw pattern into this grid format. So how did we achieve this? What we did was simply subtracting and with all the specific elements. So if at the first position was 4, so 4 minus 4 is 0, then 4 minus 3 is 1, 4 minus 2 is 2, 4 minus 1 is 3. So like instead of looking at the numbers directly, we are subtracting every element from n. So when n is equals to 4, 4 becomes 0, 3 becomes 1, 2 becomes 2, and 1 becomes 3. So now the pattern looks like a layer, right? At the borders, we can see all the 0 elements, then 1, then 2, and finally 3 at the center. So, like, how do we calculate this, right? The question is, okay, how can we calculate this? We need to identify at cell I comma j which number belongs. So for that we can analyze this matrix, and for each cell we look at its distance from top, bottom, left and right. Consider this as a target element. So if we check the row number, it is 0, 1, 2. Row number is 2, and if we check for the column number is 0, 1, 2, 3, and 4. So at row number 2 and column number 4, the element 2 belongs. So that's how, with the help of indexing, we find out the target element. And once we find the target element, we look for its directions from top, from right, from bottom, and from left. From top, it is 2 units apart. From bottom, it is 4 units apart. Similarly, from if we go in the right direction, it is 2 units apart in the right direction and 4 units apart in the left direction. So, as we recently seen, I is 2 and J is 4. That is, row number is 2 and column number is 4. So what we can infer from this is top is equals to I and left is equals to j, bottom is equals to 2 into n minus 1 minus j. If n is equal to 4, if we place 4 at the position of n, it will be 4 minus 1 3, 3 into 2 is 6, 6 minus I is 2, so that is 6 minus 2 is 4. That way we are able to get 4. And similarly, when we do 2 into n minus 1 minus j, we are able to get uh, accurate right direction. And once we find all the directions, what we will do is we take the minimum of all these 4 values. So that gives us transform number, right? So once we take minimum of all these values, like 2 4 4 2, okay, so minimum of all these 4 values is 2. And once we get the minimum of these values, we do the reverse engineering, and then that is the exact number that we are looking for in the original matrix is n minus 2. N minus 2 means, in our case, this is the minimum number, you can say the minimum number which we figured out by finding the directions with the help of direction. So once we do n minus minimum number, we are able to get the exact number that we are looking for in the original matrix. So, and that's how it matches perfectly with the grid. So let's look into the code and implementation part. So here, we have initially used outer for loop which is iterating from 0 to 2 into n minus 1. Like for n equal to 4, we are required to execute it 7 times. So it is going from 0 to 6, that is 7 times in total. So is the inner loop. And after like once it is being iterated, we are initializing and declaring all the four directions, that is top, left, right, bottom. And after the declaration, we are calculating the minimum. So C++ provides inbuilt function called as mean, wherein we need to pass two parameters at once. So we are using mean twice, once to calculate the minimum of top and left, between top and left, and another for finding the minimum between right and bottom. So once we find the minimum between these two, then we will do mean again with the resultant numbers, and that's how we will be able to find the minimum among all the four numbers. And we can simply subtract with like from n, and that way we will be able to get the exact matrix that we saw in the problem statement. And we are simply doing C out like to print the next line, and let's run the code. So we can see for n equal to 4, it is getting printed as required, like 4, 3, 2, 1. And if we submit the code, the space complexity will be big of n square, because it is nearly iterating about, the outer loop is iterating nearly about n times, and inner loop is also iterating nearly about n times. So like as these are nested loops, time complexity is big of n square and no additional space is required. That's why space complexity is big of 1. So yeah, that's it for this video. See you in the next one. Until then, keep coding, keep exploring, keep smiling. Toodles.